How are you, students? We'll come back with new physics lesson, grade 9. We will revise about simple kinetic and molecular model of matter. We will take the most important equation on this topic. The first equation describes the particle arrangement of a solid. The particle in solid is tightly packaged in a regular arrangement. Particles can't move but vibrate in the spot. These particles are packaged to each other because of the strong intermolecular force between particles, and it's moving just vibration in a short range. Don't move a translational move or rotational move. Describes the particles arrangement of a liquid. In the liquid, it's different than solid because close together but not tightly packaged. But a regular arrangement also didn't take a certain pattern. They can flow past each other, they can slide over each other because of the particles of liquid can be flow over each other because of the attractive force between particles. Intermolecular force in liquid is very low. If we want to describe the particle arrangement of a gas, the particle separated with no regular arrangement. The particles can move freely. The intermolecular force between particles in solid can be negligible, can be move freely. We will see after that it move in random direction. Random motion can move in all directions, move in a straight line and collide with each other and the surface of the container. Next question: how does density compare in solid, liquid and gas? If we want to compare between solid state, liquid state and gas state respect to its density, we know before that density equals mass over volume. So solids are the most dense because the particles are close packaged and tightly packaged. Then liquid, and last one is gas. How does temperatures affect the motion of particles? Temperature affect on the motion of the particles. We know that if we give the particle of any matters some of heat or excess energy, it will move faster. It means as the temperatures increases, particles have more kinetic energy, so vibrate, move faster. And the solid with enough temperatures, it will start to melt and be liquid, and liquid with more or enough energy, heat energy, it will start to be evaporate and be a gas. Next question: what is Brownian motion? As we speak before, the particles move in a random motion, like the constant and random movement of particle in fluid. Fluid, it means gas and liquid, resulting from collisions between the particles. Particles move at random in all directions, collide with each other and the wall of the container. In fluid state, maybe gas, maybe liquid. So this is called Brownian motion. What is evaporation? Evaporation is the escape of high energy particles from the surface of a liquid to form a gas. Evaporation just happens in a surface of a liquid because the particles on the surface have more energy and little attract to the particles of liquid, so it has ability to escape from the surface. What happens when particles of gases cools? What happens to the gases if it cools? It will, yes, they lose energy and condense back into a liquid. It will be changed into liquid. What happens if the volume of the fluid is decreased? So the fluid volume, if it decreases and its mass constant and its temperature constant, so what happened to the pressure? We said before we have three parameters we must relate to each other: temperature, volume, and pressure with constant mass or constant numbers of particles. If the volume is decreased with the constant temperatures and mass, so the pressure must be increased. So the pressure increase if the temperatures is constant. What happens if the temperature of the gas is increased at a constant volume? If the temperature is increased at a constant volume, what happens to the pressure? Yes, the pressure will increase. The pressure will increase. Next equation, give an equation relating the pressures and the volume at a constant temperature. At a constant temperature, what the relation between pressure and volume? At a constant temperature, the relation between pressure and volume, we said in the last equation, if the volume decreases, the pressure increases. So if the volume increases, the pressure will decrease at constant temperature. So the relation, it will be equal PV equal constant. P is pressure and V is the volume of the gas. B equal pressures, volume is V is the volumes by meter cubic. This is inversely proportional as we said before. Thank you. Goodbye with next part of thermal physics.